Hey, good afternoon, colleagues. I'm going to be taking you through an interesting area that forces and vectors. This time around, we're interested in investigating a balance between the left-hand side and the right-hand side of the components. So we have both the x and y, and then we look at what's happening if there's a balance. In other words, if there's a balance, we say the net effect is actually a zero. So we have the same within the x-axis and the y-axis. And when that happens, it means the object experiencing all those forces will remain stationary. In other words, there's no motion. The five questions that I'll quickly go through and bear with me. If you feel I'll be moving a bit fast, you can always replay the videos so that you have the explanation complete. So we are starting, we are given this diagram that we have here. And on this diagram, I've got my x-axis here and my y-axis. So like we normally do, if I put a force like 20 newtons, I'm going to break it down into its components, which are the horizontal and the vertical, as I create 90-degree angle here. So I'll refer to this as the x component and this is the y component. So the same will happen to all the forces that I'm seeing, like here and another x component and y. The same will apply also to this here, where I got the x as the horizontal component and the y vertical. But with this one here, the 4p newtons, we see that it's in line with y-axis. So it does not have the x component, or actually the x component will be equal to 0. So we need the information which is going to guide us as to how the calculations will be done. We are told that we have coplanar forces of magnitude 20 newtons, p newton, 3p newtons, and 4p newtons. They actually point in the direction that are shown within the diagram. The system is experiencing equilibrium. So the moment we are told of equilibrium, it means we are interested in a balance between the x and the y axis. So I'll try and write with thin of pen so that at least I can do my calculations on the top part as I'm looking at the diagram given there. So let me bring the balance. The balance I'll put an equal sign. So I'll check what's happening to the right of the object itself. So to the right, it will go after the equal sign. Then to the left, the components will also go to the left hand side of the equal sign. So let me start with the right hand side. Because I'm interested in the horizontal component where from this right angle triangle, this will be the adjacent side. So adjacent, according to trigonometric functions, cosine, sine, and tan. When you want to implement them on right angle triangle, then the adjacent works with the trigonometric function cos. So this component is going to be 20 cos theta. And when I come to the left hand side, which is before the equal sign, I've got two forces that I'm seeing here. One is 3p, the other one is p newtons. So when I break it down, I'm going to have for the adjacent side, it's going to be 3p cos 30 degrees. But remember, there's another one below, which is p newtons. But again, the adjacent side just to do with cos, so it will be p cos 30 degrees. But as I look at my first equation, because in the process we're going to build simultaneous equations, sometimes we need identities, basic like an identity tan of theta equal to sine of theta over cos theta. This identity might be yet in the process. Now, when I look at what I can put the x, there is 3p, there is p, and both the terms of cos theta. So these are like terms when I combine them, I'll simplify to 4p cos 30 degrees being equal to 20 cos theta. Right, let me try and move to the other side or where I'll deal with the y component. Now, the y component is the vertical line. Remember when I was operating on this person, I said we're not going to worry about the horizontal or the x component of the vector 4p. Why? Because it's in line with the y-axis, so it does not have the x component with. Now, within the y, as we did with the x, we're going to put an equal sign. Then we say above the horizontal, let it be the positive line. So for the y, this is going to be the first vector we might need its components, and then we also have 3p. Those are the ones which are above the horizontal. So if I'm to list them here, both the direction is the same, I'll combine them, meaning it will give me 4p plus 3p. But remember, 3p is acting as an angle 30 degrees there. So if I'm going vertically, that will be sine. So that's 3p sine of 30 degrees. That is what I'll have on my top part or the vertical component. Sorry about the miss there. Then to the left or below the horizontal, I also have two, which are this one and that one there. So let me start with the first one. First one is going to be, let me put a boundary here so that my calculations are not uh, disturbed. So we have 20 sine theta plus this is the other one where we have p sine 30 degrees. I'm expecting to get simultaneous equations out of these two. That's the x and y. Why do I say so? I've got a variable p, which is an unknown, and also variable theta. Hence, the question is asking us here to find the values of p and theta. So let me try and simplify my equations further. I know that 30 degrees is a special angle. When I'm looking for cosine of 30 degrees, I might not need a calculator because I know cosine of 30 degrees is 3 over 2. So I'm applying root 3 over 2 and 4p. So root 3 and 4, it gives us 4 root 3, but over 2, we end up getting 2 root 3p. We are done with the simplification. We put our equal sign, then to the right hand side of the equal sign, nothing changes here. 20 cos theta. Let me go and look at what's happening with the y. With the y, I have 20 sine theta, 20 sine theta, but this side is also 20 cos theta. And it looks like it's relating to this identity that I'm giving there. So maybe I'm being quizzed to say, can I transpose this so that I make 20 sine theta the subject of the formula on the second equation? So when I do so, it means I'm supposed to transpose p sine theta to the other side. So when I do so, it means to the left of the equal sign, I have 20 sine theta. Then to the right, when I transpose p sine theta, but remember there's also another sine theta there, but there's a coefficient of 3p. Now, when I combine this one here and that one, they give me 4 sine theta. And from our pure mathematics, we know sine theta. Theta is a special angle, it gives us half. So if I put 4p times half, it means this will end up giving me 2p. And when I say 2p here plus 4p, finally I'll get 6. So now I've got two equations where I'm looking for p and theta in both scenarios. Perhaps I can go down to my working space and try to solve my simultaneous equations. Let me rearrange the second one here and see if I can bring the identity that I spoke about above, which is tan. So when I do so, because they are equal signs, I'm allowed to rearrange. And when I do so, I'll have 20 sine theta equal to 6p. Then, because I'm doing it in line, these two are equal. If I bring here 20 cos theta, that will be equal to what I have on the left hand side of the x component, which is 2 root 3p. Now, in the process, we can see clear that here, numerator and denominator is same to cancel. Now I've got my identity sine theta of cos theta, which will simplify to tan theta equal to, again, on the right hand side, I can see p is common, so it can cancel. But now, what's remaining? I can see that here I have 2 root 3. Now, root 3 is on the denominator, and according to our steps, we then are being asked to rationalize our denominator because we can't get the set on the denominator. And now, in the process, we are going to have below that will be 2 times 3. Then the set will go on the numerator, giving us 6 root 3. So it looks like again denominator and numerator are not the same. So we can now come to say tan theta is actually equal to root 3. So proceeding with the calculation, I'm interested in the size of angle theta. Then I'm going to say Okay, my theta is actually arctan of root 3. So with this part now, I'll need to calculate to get the exact value. Now, in case of tan, I'll need second function. I go to tan. Then I open brackets, I bring in root 3, and I move out of the root sign, I close my brackets, press equal sign, giving me 60. So it looks like my theta here is 60 degrees. Now, the moment I find theta, it means I found P, because I can pick any of the equations that are in. When I say any, like this first one or the second one, whichever will help us to get P. Let me do it on the side so that I don't move away from the equations we had. Say, for instance, I take one of the numerator, which is saying 20 sine theta is equal to 6p. Yeah, just because I got my theta at 60 degrees, so it means this will now, when I do my substitution, come to be 20 sine 60 degrees being equal to 6p. Again, 60 degrees is a special angle where if we want to find sine at 60 degrees, that's root 3 over 2. So in essence, when I do the substitution here, root 3 over 2 times 20, it ends up simplifying to 10 root 3 being equal to 6p. Then I'm looking for p, so I'll divide both sides by 6. Therefore, my p in exact form is going to be 5 root 3 over 3 when I divide both numerator and denominator by the highest common factor, which will happen to be 2. I think basically that's what we had on the first problem. I'll continue again with the second solution or the second question. We just want to check how the examiners are testing us on those components which involve equilibrium. I hope you guys have found this assisting or